Alright, in this video we are going to be finishing up the notes in lesson 4.2. So we're going to go through examples 4 and 5. In a separate video we'll have examples 6 and 7. So this one says draw a comprehensive graph, which means we're going to have all the asymptotes, all the points plotted correctly to graph this rational function. Well, step one, you're going to find all vertical, horizontal, and oblique asymptotes that are there. We've learned to find the verticals. You're going to have to set the denominator equal to 0. So I'm going to take 2x squared plus 5x minus 3 and set that equal to 0. I'm going to go ahead and try to factor. You can use you can factor or possibly use the quadratic formula. I'm going to go ahead and say the sign to make a negative 3 at the end. You'd have to have a positive number times a negative number, you know, like 3 times 1. You would also have to have 2x times x to make 2x squared. Let's check, see if we got 5. On the outside we got negative 2. On the inside we got positive 3, which makes positive 1. We didn't quite end up with it, so I'm going to do a little trial and error. And let's take out the 3 and the 1, and let's switch them around. I'll put the 1 here and the 3 here. And that means this is negative 6 on the outside and positive 1 on the inside, which makes negative 5. We need a positive 5, so that just means I need to switch the signs. So I'll make that the minus sign to begin with and the plus sign for the second one. When we set each of these factors equal to 0, when we set each of these factors equal to 0, this one turns out to be 2x equals 1 and x equals 1/2. Okay, there's one of the vertical asymptotes right there. Or we have the other factor, which is x plus 3, which is equal to 0, and this one turns out to be negative 3. Now, those are your verticals. To do your horizontal or oblique, you have to look at your degrees. Since the degree of the numerator is 1 and the degree of the denominator is 2. Since this numerator is less than the degree of the denominator, we have learned that the horizontal asymptotes for this particular question is automatically y equals 0. Okay, automatically. Now these two steps right here, they're kind of a little bit not mandatory. They're good things to find. X-intercepts, Y-intercepts. But we're going to be picking up points, and we're going to find this information. It's going to come out eventually without going through all this. But as far as finding the x-intercept, you have to let y be 0. That's y right here, f of x. So I'm going to put 0 all right here, and I'm going to solve this out. 0 equals x plus 1 divided by 2x squared plus 5x minus 3. Now we're all in pre-calc. I'm not going to show every single step, but I will tell you that you will cross multiply, and 0 times all this down here, this trinomial is still 0. And then 1 times x plus 1 is x plus 1. And when you solve for x, you get an answer of negative 1. So that means that this is your x-intercept. Okay, the x-intercept is negative 1. And we're going to be able to plot that on our graph, and we can actually do it right now so we don't forget about it. Here's the x-axis. We're going to be graphing it, and I'm going to go ahead and put a nice big point right here. This is going to be our x-intercept. Now, one thing I want you to notice is, if you want to determine whether or not a graph crosses the horizontal asymptote, it can cross the horizontal asymptote. It cannot cross a vertical, but it can cross the horizontal. Well, the horizontal asymptote was right here. It said it was y equals 0. You have to actually solve the equation when y is equal to 0, only because, I'm going to change colors, this number right here is 0, only because this number is 0 right here. If we had found a different number here, this would be a different number here, and you would solve an equation. But since we already solved that equation right here, and we did all the work right here, and we said the answer was negative 1, that means that when we chose the horizontal asymptote, which is 0, and it got an answer for x, it means it is going to cross that horizontal asymptote. So let's go ahead and graph those horizontal and vertical asymptotes so you can see that. For instance, the horizontal asymptote, let's go ahead and do y equals 0. That is hoy 0 goes right through here. You're going to put a nice dotted line. Yes, it is kind of hard to see when it's on the axis. You might want to spread it out a little bit farther past the axis on both sides. Make sure you put a nice big arrow on each side. We also have x equals 1/2. And here's 1, here's 0, so 1/2 is right in between. So you're going to draw in a nice dotted line going right through x equals 1/2. Put arrows on either side. And we also found a vertical asymptote to be x equals -3. -3 is right here, so we'll go ahead and draw a vertical asymptote in. Okay, so we're now at the point where we need to start graphing this, okay? And when you're graphing this, you have to graph this by sections. And when I talk about sections, we're going to be picking points from the left over to the first asymptote. That's going to be our first section, okay? That's where we're going to start. We'll get to the rest of it as we pick points. We're going to have an XY chart. I'm going to go up and get up here and draw a nice straight line because it's hard to do with my little wireless board here. Let me draw a nice straight line, and we're going to pick some points. Well, I like to pick a point at the end of the section. I like to pick a point kind of in the middle of the section. We'll do -7 or -6. We'll pick -6. And we want to get right up against the asymptote so we can see which direction this graph is going to curve. Well, since this is -3, just on the other side is -3.1. Okay, so what you're going to do, and I'm going to close off this section because this is the section that, you know, we just got done saying it went up to that vertical asymptote. So now, I'm going to show this one time, and that is it. For the rest of this, you guys are going to be doing it in your calculator yourself, or, you know, I'm just going to be showing you the answers to the problem. So what I'm going to do is I'm going to take this -10, and I'm going to be placing it in right here, okay? I'm going to put it in -10 for x here, here, and here. But since you don't have a graphing calculator, you will not be allowed to use one on your test. You have to be able to do all the work correctly. So I'm going to go back out to the main screen. I'm going to go ahead and type this in like a scientific calculator. So I'm going to use a parenthesis, and it says x plus 1. So I'm going to do -10 plus 1. I'm going to close that parenthesis that defines the numerator. I'm going to divide it by the denominator, and I need another parenthesis to say, what is the denominator? Well, it's 2 times -10 squared. 2 times -10 squared, so I got to close it and square it, and then plus 5 times -10, and close it, and then -3. Now at the very end, I have to close the denominator, so that's why there's a parenthesis here. I'm going to go ahead and hit enter, and that answer is approximately -0.06. So I'm going to come back to here, and I'm going to put in -0.06. And let me go ahead and change colors here. And the reason I'm going to change colors so you can see it really easily on the graph, so that we're not confusing all the asymptotes with the points. So what all that tells me is that right here, instead of being up because it's negative, our graph is actually in this bottom section down here, okay? So we're going to be starting down there at -10. Now, for the rest of this problem, I'm going to be writing in the answers here. You are expected to be typing these into your scientific calculator. So, for instance, at -6 in my calculator, it's -0.12, 13 if you round. Either way, that doesn't really matter. The point is that it's just barely below -6. At the asymptote, -3.1. Let me check that one on the calculator. That turns out to be -2.9. Now at -3.1, 1, 2, 2.9 puts us about right here. The whole point of this is this graph follows this asymptote, and then it curves, and it follows the asymptote going straight down. You're going to put arrows on both sides, and you have that section graphed. Now the next section will go from the inside of this asymptote to just the inside of this asymptote. So we're going to be dealing with numbers right in here. Well, I'm going to pick a point right up against the asymptote here. Since this is negative 3, this would be negative 2.9. We already do have a point here from the x-intercept, technically. So let's try to pick up points, and we'll treat this as the middle point, which we already know is negative 1, 0. I'll just go ahead and put that on there. And how about we pick one right up against this asymptote? Well, this is 1/2, which is also 0.5. So how about just left of this 0.4? Okay, I'm going to go back to my calculator again. And we're going to put in negative 2.9. And that would be 2.7. Which is negative 2.9, and then positive 2.7 puts us about right here. We also have 0.4. And that comes out to be negative 2.1. Which right here, going down 2.1, puts us at about right here. This graph is actually following this asymptote. And then it starts to curve, and then it follows this asymptote on down. And you're going to put arrows on both sides, and you have the middle section graphed. Then we're going to go to the right side. Okay, I'm going to close this section off, and then we're going to pick points to the right of this asymptote, which very close to it, close to 0.5, is 0.6. And then we're going to choose numbers like 5 and 10. You know, just do something in the middle and something at the end. I'm going to go back to the calculator again, and 0.6 is about 2.2. 5, little calculator error here, I have to fix that. 5 is about 0.08, and 10 is at 0.04. So all these numbers are positive right here. Right next to the asymptote, it's up at 2.2. At 5, it is at 0.08, which is barely above the asymptote. And at 10, it's at 0.04, which is, again, is barely above the asymptote. This particular graph is trapped in this section where it's following the asymptote. It curves, and it hits these other points, and it follows the horizontal asymptote. And as soon as you have all the sections graphed, this problem is complete, and that completes example number 4. So we're going to move it on to the next example. All right, so example number 5. First, we're going to find the vertical asymptote. So x minus 3 has to be set equal to 0, and that says that your vertical asymptote is 3. So over here at 3, I'm going to go ahead and sketch in that dotted vertical asymptote that the graph can never cross. It can never cross a vertical asymptote, ever. So it can be on one side or the other, but it will not be drawn across. A horizontal asymptote, let's see. If the degree of the numerator is the same as the degree of the denominator, then you will take the number in front of that x with the highest power divided by the number in front of the x with the highest power, and that means that y turns out to be 2 divided by 1, which is also just y equals 2. And that is a horizontal asymptote right at a height of 2 on the y-axis. Okay, so over here, again, these right here are something you don't have to do on every single problem. You know, the x and y intercepts, you know, they're definitely helpful to find. But if you're going to find the x-intercept, you have to let y be 0. That's this guy right here. And that's why you see this 0 here. We want to equal to 0. Well, we cross multiply. X minus 3 times 0 is 0. And 1 times 2x plus 1 is 2x plus 1. When you solve that problem, 2x turns out to be negative 1, and x turns out to be negative 1/2. So that's just a point. It says, hey, you know what, negative 1/2, and I'm going to change colors again, like I did last time. Negative 1/2 ends up being about right here. That's an x-intercept. You can also find a y-intercept. That means you have to let x be 0. So that would mean that you would solve the problem 2 times 0 plus 1, that's the numerator, over, and then 0 minus 3. So that would be 0 plus 1, which is 1. 0 minus 3 is negative 3, so that's just negative 1/3, which puts us really close. They're really close together. What that pretty much tells me is this graph is probably curving right through here. Okay, you can see the kind of the way they're angled here, and they're going to be trapped by these asymptotes. Okay, so let's see here. Another question that we're going to answer by picking enough points, but does it cross the horizontal asymptote? What number was the horizontal asymptote? It was 2. You can solve this problem. You can do the same thing we did before, except you don't have a 0, so it's a little tougher. You have 2 times x and 2 times negative 3. So that would be 2x minus 6 equals 1 times 2x plus 1. And if you notice, the x's are going to cancel out on both sides. And since this is a false statement, there is no solution. And since there's no solution, the question is, does the graph cross the horizontal asymptote? And the answer is no. So, but that's not really helping us graph. We just know that you will not be drawing a graph line through this line. It's either going to be above it or below it. I'm going to do what I did last time. I'm going to use every little space I have on this paper. So I'm going to draw a vertical line right here. And we'll put as many points in this little area as necessary. I'm going to start over here in the very left, negative 10. I'm going to go from here to the vertical asymptote. So somewhere in the middle, how about like negative 4, negative 3, somewhere in that range. And how about somewhere very close to the asymptote? This asymptote is at 3. How about 2.9? And I'm going to close that section off. So I'm going to go back to the calculator, and I'm going to do each of these. And at negative 10, it's 1.5. So at negative 10, 1.5 puts us about right here. So you can see it's not above the asymptote, it's below it. So it's in this little area here. At negative 4, it's at 1. And at 2.9, let me get that one real quick. At 2.9, it's negative 68. That is just enough information for us to know that it's way down here, somewhere way down there. So I'm just going to draw this. We got enough points here. I'm going to go ahead and draw this, curve it through these points that are already here, and then just curve it down the asymptote. Okay, eventually it's going to hit negative 68 way down here somewhere. Now I'm going to go to the other side of the asymptote. Well, this is 3, so the other side would be 3.1. And how about somewhere in the middle of this section, about 7. And then at the end, we'll do 10. All right, and I think that should be it. Once we do this, we're done with this question. So 3.1, it turns out to be 72. Wow, look at that. That's huge. We just know that this graph is way up here. It's probably in this section here. Okay, and it is in this section up here. Since that number was way up there, we might need one more point. We'll check it out. Okay, for 7 is 3.75. So it's 7, 1, 2, 3.75 puts us about here. And we also have a 10. And 10 works out to be 3. So at 10.3 we're here. We know it's going to come through here, and I'm more than happy with drawing it right here. If you want to do the number 4, just to let you know, if the number helps us out at all, the number 4 is at 9. Okay, so if you wanted to do another one and say, hey, I want to make sure this is right, that would put us right here. So you can see it's coming down here, it's curving. And as long as you get that general idea with points that proves that it's in that section, then you're good. And that finishes up example number 5, and we'll do numbers 6 and 7 in the next video.